So we have 10 liter container with 4 gram hydrogen gas and 28 gram nitrogen gas. So you need to find the total pressure of the
Madam share
Huh?
screen ke?
Huh?
Madam share screen ke?
Alamak, lupa ah.
Tak nampak.
Sorry. Hmm. Okay, ni nampak tak?
Nampak, Madam.
Nampak full screen kan? Okay. Ada dua gas, a mixture of gases, which is hydrogen and nitrogen. And hydrogen is 4 gram, while nitrogen is 28 gram. So in 10 liter container, we need to find the total pressure of the gases mixture. So here we are applying the Dalton law, where the total number of mole is 3 mole. Okay, cari mole hydrogen dan mole nitrogen. And the pressure is using PV and RT for each of the gases. So total pressure, okay, tak payah cari each pressure pun sebab dia kata total pressure kan. So total number of mole. Okay, using the PV and RT. So total number of mole is 7.48 atm. After that, we need to calculate the partial pressure of the hydrogen. So we already have the number of mole of hydrogen, and total number of mole is 3 mole, and total pressure is 7.84. So kita gunakan mole fraction pun boleh. Mole fraction of hydrogen times the pressure. So it is 2/3 mole times this one. So partial pressure of hydrogen will be 4.99. So that one is very simple. So what will happen if the gases mixture is heated to 550? So kita tengok dekat formula PV and RT. Okay. Kalau temperature dia, okay, ni cari partial pressure hydrogen dan nitrogen daripada total pressure tu. Sekarang kita nak tengok what happen if the gases mixture heated to 550. So, this is applying the kinetic molecular theory, where when we provide heat or increase the energy, so the kinetic energy of the gases will increase, and then the frequency of the collision increase. So frequency collision each of the collision will exert the pressure. So at the same time, the pressure of the gases mixture increase. So the effect is pressure gases mixture increase. Okay, right. Kita nak tanya soalan. So this one is kalau revise kinetic molecular theory, dia bagi tahu kan effect increasing the pressure. Okay, next, under the same condition of temperature and density, determine which gases behave ideally. So sama ada CH4 ataupun SO2. So SO2 behave less ideally compared to CH4 because of the size of SO2 is bigger. So lagi besar dia punya size, dia volume tu pun lebih besar, dia deviate daripada ideal. So SO2 is significant. Okay, volume dia significant lah sebab size dia besar berbanding dengan CH4. So siapa yang volume significant, dia menjauhi ideal gas. Sebab ideal dia kata volume is not significant ataupun volume is negligible. Then kita boleh kata SO2 menjauhi ideal. Ataupun kita boleh kata SO2 real gas lah. Ataupun deviates significantly from the ideal gas. Sebabkan faktor utama dia adalah faktor size. So size related to the volume. So remember that dua assumption untuk menjadi ideal gas adalah volume negligible, untuk molecular force also negligible. Next is experiment where gelatin added to water. So the water become viscous. So what is the relationship between viscosity and intermolecular forces? Ni dah bincang ke belum sebelum ni? Dah. Sama dengan dulu je kan? So viscosity tu resistance liquid to flow. So kalau intermolecular forces dia kuat, so So the molecule hold to each other very strong. So then the viscosity will be higher. Susah nak flow. Okay, now we go to question number 2. You have zinc and HCl collected, and HCl reacted. So the hydrogen produced is collected over the water. Then the volume of the gas collected is 7.8 gram, 8 liter. The pressure is 0.98. So you need to calculate the amount of zinc metal consumed for the reaction. So kita kena buat stoichiometry, berapa banyak zinc yang reacted dengan berjaya menghasilkan hydrogen gas sebanyak 7.8 liter ni. Okay. First of all, total pressure yang collected tu adalah over the pressure over the liquid is the total pressure, which is the pressure, the mixture of the pressure of water and the hydrogen. Okay, sekarang kita nak 7.8 liter volume ni ataupun pressure 0.98 ni adalah pressure bagi hydrogen sahaja. Okay, so total pressure tolak vapor pressure. Kenapa kita tolak vapor pressure? Sebab tadi ada mixture kan. Sebab it's collected over the water. So the mixture of the gases also include the water. So kita buang water dan kita dapat pressure hydrogen gas sahaja, which is 0.949 atm. Okay. Applying PV and RT, so we get the number of mole of hydrogen produced. So 1 mole of hydrogen produced when reacting 1 mole of zinc produced. When we react 1 mole of zinc. So here zinc is the limiting reactant, right? Okay. So the amount of mole hydrogen produced is formed when 0.3027 mole of zinc reacted. Therefore, the mass of zinc reacted is 19.8 gram. Okay, so kita cari dulu yang product form, the number of mole, and then apply stoichiometry. So dapatlah 19.8 gram. Okay. Next is the phase diagram. So ingat lagi tak phase diagram? So this is the phase diagram of CO2. How do we know it is CO2? Because the slope is positive slope. Solid, liquid and gas. Name the process that occurs as CO2 undergo phase from 1 to 2. Daripada 1 to 2. So it is solid to liquid. So solid to liquid is a melting process. And then physical states of A, B. A dengan B. So A ni adalah antara solid dan liquid. So atas line, it is the border of solid and liquid. So solid and liquid exist in equilibrium. While B, solid and gas exist as in equilibrium. Solid and gas. Liquid and gas, sorry. Ni solid liquid equilibrium, ni liquid gas equilibrium. Okay, boleh tak? Laju Tidak bosan. Okay, kalau you nak tanya je tau. Terus interrupt. Directly interrupt me. Okay. Next is to explain the formation of solid CO2 dry ice at room condition. So, macam mana kita nak dapat formation solid CO2 dekat at room condition? Dia kata impossible to form CO2. Sebab apa? Kita nak ubah daripada sebab kita telah melalui triple point. So triple temperature is below room temperature. So dia punya triple point tu is below room temperature. So dia tak mana tadi? Okay, this one is the triple point. So room temperature atas lagi. So the triple point is where solid to liquid or solid to gas. So kalau kita nak ubah dry ice tu ataupun CO2 tu, tak boleh ubah dah. Okay? Sebab dia punya yang dia boleh ubah tu maksimum temperature dia adalah pada negative 70 negative 57. Tapi kalau room temperature 31, dia dah duduk kat sini lah. So tak boleh nak ubah pun. Okay, the answer is the triple point is below the room temperature. So we go to the van der Waals. Nak faham van der Waals ni, dia kena ingat dia adalah berasal daripada PV and RT, where this is the correction of the pressure and the correction of the intermolecular forces. So sekarang dia kata determine and explain whether hydrogen and H2S molecule has higher value of A and B. Okay. So H2S molekul dia lebih besar daripada hydrogen gas. So it has higher value of A and B compared to hydrogen. Okay, ini disebabkan oleh H2S is more polar than hydrogen. So hydrogen adalah non-polar. So H2S is higher value of A. Sebab apa? Strong intermolecular forces, polar molecule is stronger than non-polar molecule. So therefore, H2M molecule has higher V value because it has bigger molecular size. Therefore, volume is higher. Okay. Pertama, A ni is correction for the intermolecular forces and B is the correction for the volume. So for the H2S, A and B is higher because intermolecular forces is significant and the volume also significant. Sebab molecular size H2S greater than hydrogen. That's all. Okay. So saya nak conclude lah, nak simplify. This one is the correction for the intermolecular forces. So this one is for volume. So ingat untuk PV and untuk ideal gas, we are neglecting the volume and intermolecular forces. So you kena baca balik lah kalau tak faham, kena revise balik kinetic molecular theory assumption dia. You assume there's no intermolecular forces and there's no volume of the gas particles ataupun sangat kecil sehingga boleh diabaikan. Okay. So what's the effect of the A and B value that related to the boiling point? So A value is related to boiling point sebab apa? A adalah correction bagi intermolecular forces. So affected tak terhadap boiling point? Yes, affected because H2S has strong intermolecular forces. So kalau strong intermolecular forces, boiling point will be higher because boiling point is the process of transforming from liquid to gas. So dia kena absorb banyak energy untuk overcome the strong intermolecular forces. Okay, so A dia akan higher dan menyebabkan higher boiling point. So keyword dia adalah A. The first part is the intermolecular forces. Sekejap nak minum. Okay, next is question number 4, which is the Charles law of the kinetic perspective. So yang ni tengok nota lah. Charles law dia kata kalau temperature tinggi, volume pun akan tinggi. So supaya kita tak hafal, once kita panaskan satu gas, gas akan mengembang. So volume dia akan besar lah. Ataupun bila kita naikkan suhu, molecule absorb the energy and the kinetic energy is increased. So they are colliding to each other. So they are moving faster and the pressure is higher. Sorry. Pressure dia di-constantkan kan. So volume dia besar. Okay, pelanggaran tu menyebabkan pressure dia tinggi. Tapi since kita nak make sure the pressure is constant, so volume tu dibesarkan. Okay. Ataupun simple je lah. Kalau kita panaskan satu gas, kita nampak pengembangan gas. It's because of the volume increase. Next is piston of the cylinder holds 7 grams CO2 at 160 grams, 160 degrees Celsius, 110 kilopascal. How many grams of CO2 will hold at 27 under the same pressure? So sekarang kita gunakan formula this PV and RT, and then you adjust the molar mass dia. So kita dapat dia punya volume of the piston tu, which is 5.21 liter. So dia punya capacity gas yang dia boleh hold tu adalah 5.21 liter. So menggunakan pressure yang sama, kita kata how many gram of CO2 will hold at 27. So kalau 27 pula dengan pressure 110 kilopascal pula, berapa pula amount of CO2 yang dia boleh simpan di piston tu. So kita masukkan dalam PVNRT, you masukkan, you ubah temperature dia 27, okay, pada volume yang sama, iaitu volume 5.21 tu. Okay, mula-mula kita tak tahu 7 gram ni dalam at this condition berapa liter gas itu. Sekarang gas volume yang sama, tapi berapa mass CO2 dia boleh hold. It is 10.11 gram. Next is when solid is heated in a closed container, it undergo the phase changes. So you need to describe the process. Okay, so solid heated in closed container. So solid akan the solid particles gain energy. Lepas tu energy tu menyebabkan dia vibrate more quickly and energetically, and the temperature approaches until they keep absorbing the energy until it approaches melting point. So the particle have enough energy. So energy yang dibekalkan tu diserap oleh particle tu untuk buat apa? Overcome their intermolecular forces. So asalnya solid ada intermolecular forces. Now the intermolecular forces is being overcome by the energy that the particle has. So particle is moving freely. So solid start to change into liquid. So bagi tahu bila dipanaskan, tenaga diserap. Tenaga serap tu untuk buat apa? Untuk overcome intermolecular forces. Sampailah approaching their boiling point ataupun melting point. So solid bertukar pada liquid. Okay. Next, using copper, diamond, sulfur and sodium chloride, identify the tight interparticle bonding that form the states of metal. Kalau metallic bond, dalam Cu2+, dia adalah metallic bond. So kalau metallic bond, of course kita akan relate dia dengan C of delocalized valence electron. Kalau diamond pula, it is strong covalent bond, and then they will form a giant covalent solid. Okay, for sulfur, it is non-polar molecule, and dia punya intermolecular forces hanyalah van der Waals forces sebab dia molecular covalent solid. Okay, while in sodium chloride, it will form the ionic bonds between Na plus and Cl minus ion. Okay, second part is kita dah habis chapter 5. Now we proceed to chapter 6. Semua dah buat. Okay, so this one 1000 Kelvin. Okay, we have CO2, CF4 and COF2. Okay, then the Kc is 0.5. If 0.08 mole of CO2 was allowed to react with 0.08 mole CF4 in 5 liter container, so the system reach equilibrium. Calculate the concentration of each gases at equilibrium. So kita nak cari ni. So something that you want to find at equilibrium, either molarity or pressure, kita kena construct R stable. Okay. So the initial concentration. So nak cari initial concentration when you have the initial number of mole. So cari dia punya molarity. Volume dia bagi 5 liter. So ini semua gas. Mole over volume. So it's molarity. Initially, kita cari number of mole. Number of mole given. So we find the concentration. The concentration is 0.016. Okay, sebelum reach equilibrium, COF2 belum dihasilkan lagi. Kita hanya ada reactant saja. And then it changed by minus X and increased by 2X. Okay, tengok dia punya coefficient number. Finally at equilibrium. Okay, so sekarang macam mana kita nak selesaikan X? Okay, ada dua cara nak selesaikan X. Sama ada dia bagi maklumat degree of dissociation alpha ataupun dia bagi Ka Kb. So the value of K given Kc kan, Ka Kb, Kc ataupun Kp. So the value of Kc given is 0.5. That means you need to write the expression and substitute the value of X into the expression and you can find the value of X. So kita substitute masuk dalam expression kita. So X square of this one equal to Kc. So what quadratic we have two value. So if you dapat negative value, the negative is to indicate the value of X is the concentration kan. So mana ada concentration negative. That's why this value of X with negative sign is invalid. So take the first value of X. So now we already have the concentration of both reactant and product at equilibrium. So substitute the value of X, then you can find the concentration of the equilibrium of CO2, CF4, 0.01. So dia minta cari apa? Concentration at equilibrium. Yeah, this one and this one. Ada soalan? Ada cara lain untuk nak tanya ke? Next. Take the effect of increasing pressure on the position equilibrium. So sekarang kita nak tengok increase the pressure. So ni Lechatelier's principle lah. So the disturbance now is increasing pressure. So our correction now is to decrease the pressure. So it will shift to the lower number of moles. In this case, kita tengok dia, kita nak prove mathematically. So we use the Kp equal to Kcrt delta N. Okay, what's the value of delta N? The number of mole of product minus reactant, 2 minus 2. Substitute. So you dapatlah Kp dia 0.5. Dia suruh calculate Kp lah. So effect of pressure kita pakai Lechatelier's principle. So dia pergi ke kanan atau kiri, kita tengok disturbance dia adalah increase the pressure. So our correction is to reduce the pressure by shifting to the lower number of mole. So at the left side we have 2 moles. So ni kita tahu 2 moles, 1 mole CO2, 1 mole CF4, 2 moles. Right side it has 2 moles. That means both sides are 2 moles. So tak pergi ke mana-mana lah. There's no change in the equilibrium position. Since both number of moles both sides will be the same. Next question is, we have the reaction of CO2 and water producing the glucose and oxygen. Okay. Now you are given the concentration of water, the CO2, and the oxygen. Okay. So this concentration is at what condition? Is it at equilibrium or at the initial? Macam mana nak tahu?
Equilibrium.
Macam mana kita tahu at equilibrium? Dia kata apa? The equation is noted the following equilibrium concentration. Oh, okay. Okay, so maksudnya dia dah reach equilibrium lah. So directly masuk dalam KC. Tapi dia minta KP kan. So cari KC dulu. Bila dah ada KC, masukkan dalam formula KP, cari delta N. Okay, cari delta N yang betul lah yang masuk ke dalam KP expression. So sebelah kanan 6, itu 7 tolak 7 tolak berapa ni? 12. Betul ke? Mana tak? 6,6, 12. Ini solid. Okay, solid tak masuk ah. Sorry. Solid tak masuk dalam expression. So the number of mole tak kira. So 6. 6 tolak dengan 12. So it is negative 6. So masuk dalam KCKPLT, delta N dia adalah negative 6. The KP value is 5.02 exponent negative 18. Okay, senang je kan? So dah dapat value KP. Ya, tunjuk lah. Saya rasa semua orang pakai cara yang pertama. Okay, then next. Determine the initial mass of CO2 involved in the above reaction. Ini berapa banyak? So, when you are given the number of the concentration, initial, kita tak tahu, kita pun wakilkanlah sini. For ice stable semua, tapi kita ada concentration at equilibrium. Sekarang kita nak cari initial. Ada KCKP, ada equilibrium concentration, tapi nak cari initial. So, tengok ni. Ada initial kan, is 9.3 minus 6x. So the value of x is this one. Only value x. Maklumat yang tak ada. A dia 0.924 mol. X. Kat mana kita dapat value x lah sebenarnya? Saya cari value x tu. Ada kat sini. Mana value of x. So substitute masuk dekat sini. Saya dapat initial dia. The initial dia is 0.9324. Tengok kat sini. Okay, that means this one minus the value of x. The 6x. Dapat initial. Okay. So dia tanya mass. Sekarang kita ada concentration, volume given, and then dia cari number of mole. So number of mole times smaller mass, dia dapat mass dia 41 gram. Kita soalan tutorial je lah. So C. Explain how the equilibrium position would be affected for each of the following changes. Water vapor added, temperature increase. So kalau water vapor is added, kita telah menambahkan this one. The reactor is increased, right? So kalau you tambah reactor dekat sini, dia akan shift ke mana? Tambah reactor, shift to the right side, to the product. So it will shift to the right. Okay. Tapi kat sini dia tambah apa? Water vapor. Tapi kalau dia tambah water liquid, tak adalah no change in equilibrium. Sebab solid and liquid does not change concentration dan dia tak masuk pun dalam CKP expression. Then when the temperature increase, the equilibrium shift to the right. Apa shift to the right? Okay, look at here. We have delta H positive. That means it is endothermic reaction. Endothermic reaction maksudnya the heat is located at the reactant. Kat sini. So, you ambil pensel, you tulis kat sini heat dekat sini kan. Panas kat sini. So, temperature increase, panas. Takkan nak duduk kat tempat panas. Lari ke tempat sejuk. Sebelah kanan ni sejuk. So, it shift to the right. Settle. Okay, next is soalan nombor 3. We have 2 liter container. Initially initial quantity of chlorine, H2O, HCl, oxygen. Okay, semua dia bagi. Determine whether the reaction is at equilibrium or not. Okay. So kalau tak equilibrium, predict dia ke mana. So what you need to do is you have all the number of mole and then the Kp. So you kena compare Qp and Kp. So macam mana nak cari QP when you have all the number of mole? So kita cari dia punya pressure ataupun initial pressure of each of the gases. So kita cari pressure oxygen. Okay, semua guna PDNRT, pressure water, pressure liquid semua. And that is their partial pressure each of the gases. So now insert into QP. So masukkan dalam QP, the QP is 0.481. And then let's compare with the KP. So QP 0.48. KP dia tadi berapa? KP dia 6.4 exponent negative 6. So QP mana pen? Kita buat macam ni. Alamak, tak ada. QP is greater than KP kan. So you buat fragment kan. Tak boleh buat macam ni. Kalau nak buat fragment dia kena Q dulu. So QP greater than KP, so it will shift to the left. It's not at equilibrium. Nak pergi mana? Pergi ke shift to the left. Soalan lah. That means banyak produk. Produk banyak. So nak reach equilibrium, we shift to the left. Macam more. Okay, dah habis. Okay. Habis. Oh. Am I too fast? Okay. Ada mana-mana soalan yang nak tanya?